Hello, ladies and gentlemen. Mr. Deaver here. Welcome back to science class. Today, we're going to be learning about Isaac Newton's third law of motion. For every action, there is an equal and opposite reaction. Let's jump right into this. All right, so you're going to be working on this little lab sheet here, okay? And virtual students, just make sure that you click on the video links and you'll be able to follow along even though you won't actually be able to do the experiment, although you're welcome to if you have the materials. All right, so Isaac Newton's third law states that for every action, there is an equal and opposite reaction. In other words, forces never act alone. Instead, they are always found in action-reaction pairs. A rocket is a fitting example of Newton's third law. When a rocket starts its engine, the rocket pushes high-pressured gas downward towards the ground. This is the action. The reaction is seen in how the high-pressured gas pushes the rocket up and away. Draw a diagram in the space below that illustrates Newton's third law with a rocket. Be sure to label the action-reaction pairs. Okay, let's do this one together. Okay, so check this out. Let's draw ourselves a rocket. Oops, hold on. There we go. Okay. There's my picture of a rocket. I want you to draw something like that. Okay. We'll even put a little window so the astronaut can look out. All right, now, when the rocket ignites, it starts blasting high pressure gas out the bottom. Okay? Now, that, ladies and gentlemen, is the first thing that happens. And the first thing that happens is the action. So, we're going to draw an arrow showing that this, okay, the gas coming out is the action. All right, that's the first thing that happens. Now, in response to that, the rocket ship moves in the opposite direction. So the action is the rocket pushes out the gas, and the reaction is that the gas pushes the rocket. Okay, action, reaction. All right, let's write that over here. We're just going to make ourselves a little note. Action and reaction. So the action is the rocket pushes out gas, and the reaction is that the gas pushes rocket opposite direction. Because remember, Newton's third law says that for every action, there's an equal and opposite reaction. So the action is downwards, the reaction is upwards, okay? Equal and opposite. All right, now we're going to move on. Okay, now let's take a look at these three examples. And for each one, you're going to label the action-reaction pair. Remember, the action is the thing that happens first. The reaction is what happens in response because forces always come in pairs. So here we are looking at our squid, okay? Over here we got our squid. Let's see what we can do here. All right, now as you can see, the water comes out and it moves in the opposite direction. So which one happens first? Does the squid move first or does the water shoot out first? If you said the water comes out first, you are absolutely right. So the first thing that happens is the action. All right, the first force. The squid, you could say, applies a force to the water. Okay, the squid pushes the water out one end of its body. And because of that, the reaction is that the squid moves the other way. Action, the thing that happens first. Reaction, what happens second. All right, now this next one is a girl jumping out of a boat onto a dock. As you can imagine, some things are going to happen in this picture. Okay, now what's the first thing that happens? All right, what's the first thing that happens? If you're standing in the front of the boat and you want to jump out onto the dock, you have to take a step. In other words, when you take a step, you're pushing backwards on the boat. Okay? So the first thing that happens is the girl pushes backwards on the boat. We're going to label this the action because it's the first thing that happens. Now, because she pushes backwards on the boat, what happens to her body? Well, you might have guessed correctly. She goes the opposite way. Reaction. Action pushes backwards on the boat. Reaction jumps forward onto the dock. Action, reaction. Now let's take a look at our last one, and this last one may require a little explanation so you know what's going on. What we've got here is we've got this boy who has just thrown a basketball, okay? You can see the basketball kind of has these little lines on it to show you that it's moving. Okay, so the boy threw the basketball. Now which way is the boy moving? You can see the little arrow down here. So we got to ask ourselves, if this is an action-reaction pair, what happened first? Did the skateboard move first, or did the ball get thrown first? And if you said the ball gets thrown first, you're right. First thing that happened is the boy threw the ball, okay? That's the action. And believe it or not, if you throw a ball hard enough, because forces come in pairs, it actually pushes back on you a little bit, just a little bit. And so if you're on a very smooth surface, when you throw that ball, the reaction is that you're gonna actually roll the other way a little bit, okay, just a little bit. And it's the same thing as if you were on roller skates and you pushed against a wall, okay? You push the wall one direction, that's the action. You roll the opposite direction, that's the reaction, okay? Action, reaction, forces come in pairs. All right, now here's where the experiment starts. And if you have this stuff at home, it's a lot of fun to do. If you don't stress about it, okay? I'll tell you what to do in just a minute. So you're going to get in groups of 4 if you're in my classroom. 2 of you are going to hold the opposite ends of a string. You're going to make sure you hold it tight and you hold it at about the same height. We don't want the balloon rocket going downhill or uphill. We want it traveling flat. Next, one of the students is going to take a straw and thread it onto the string. So you've got this string with a straw on it. The last student is going to blow up the balloon. Actually, you're going to bring it to me. I'll blow it up for you using my air compressor. And then you're going to tape the balloon to the straw and let it go. Don't let it go till I say ready, set, go, because I'm going to time how long it takes to go across the room. Shooting across the room on the string, a balloon rocket. Now, if you're a virtual student and you don't have these materials and you just kind of want to see, like, whoa, what is this? What's going to happen? Well, there's a video for you can watch, okay? It says, if you are a virtual student and don't have these materials, just watch this video, okay? So you can have an idea of what's going on. And then what we're going to do is in this space, we're going to make a drawing, and I'm once again going to have you label the action-reaction pair, all right? I'm going to help you make the drawing, and then you're going to label it. All right, so here, let's make a little drawing together. First of all, we've got, whoa, what happened there? First of all, we've got a string. It's been stretched across the room. Over here, we have a person who's holding one end. And on the other side, we've got a person holding the other end. Now, on this string, there is a balloon. First of all, there's a straw. I know, it's a bad drawing of a straw. But anyway, there's my straw. And then attached to it is this balloon, which has not, it's been blown up, but not tied off. Really important that it doesn't get tied. Okay, someone has to just be holding it right there. All right. So somebody is holding this balloon right there. It's taped onto this straw. And when you say ready, set, go, the person who's holding the balloon right here is going to let go. And as you can imagine, a lot of air is going to come out that end of the balloon. and the balloon is going to start to travel. So what I want you to do now is I want you to label what is the action and what is the reaction, okay? Go ahead, draw some arrows and label action, reaction. All right, ladies and gentlemen, you're almost done. The last thing I need you to do is to simply create now an explanation. You need to show me that you kind of understand this a little bit, okay? It's starting to make some sense. So here, the last task for you is in your own words to explain how Newton's third law of motion relates to the balloon race. In other words, how does Newton's third law explain for us why the balloon rocket works? Now you must use the following terms in your explanation. You have to somewhere refer to Newton's third law. You have to say something about the action force and something about the reaction force. And remember, use those words to explain why the balloon rocket works. Why does it go? All right. Go ahead, explain your answer, and that's all for our lab today. Have a great day. Mr. Deaver out.